Hello, Math 133 students. I've received a request for help with this question, which is 6.2, number 44, if you open the textbook. I'm going to click View an Example because, of course, I do the examples. It says, suppose that a recent poll found that 39% of adults believe that the overall state of moral values is poor. Complete parts A through C. And then for 600 randomly selected adults, compute the mean and standard deviation of the random variable x, the number of people who believe that the overall state of moral values is poor. Okay, well, just for starters, this is obviously binomial. I mean, for one thing, it's in the binomial section, which is 6.2. But let me just do a little bit of work here. So let me insert an equation. There it is. Just so you can see. All right, n is 600. Right? The probability of success, well, first of all, let's define success. Success is poor, right? That the believing the overall state of the moral values is poor. And you know that because they tell us that x is the number of adults who believe the state of moral values is poor. And because it's saying poor right here, that's how I know that poor must be my success. All right, that's fine. That's good enough. I mean, technically we could find Q and all of that. Well, here, let me throw those in. The probability of success is 0.39 because that's also the percentage of people that believe moral values is poor, right? So 39%. So 0.39. Q, therefore, which is the probability of failure. So that'd be people that believe it's not poor, right? If you wanted to say, you know, failure equals not poor, right? They don't believe that the moral values are poor. That would be everybody else. That's 1 minus 0.39, which is 0.61. I can show you that in Desmos if you want. Let me grab Desmos real quick. Graphing calculator. 1 minus 0.39, right? Because they have to be complements of each other because they're the opposites of each other. Okay, so how in the world does this help me? Well, because I know there's a formula for the mean and standard deviation from section 6.2, namely that the mean, which is mu, so I'm just looking for the symbol. I know it's in this list somewhere, but I can't see it. Oh, there it is. Geez. Mean is NP, or N times P. We don't bother saying the times symbol, but it's there. It's implied. All right, so N times P, which would be 600 times, let me use the symbol. There it is. P, which was 0.39. So I'm going to go back to Desmos over here. Sorry, that's cut off a little bit at the top, but it is Desmos. All right, so I'm going to say, hey, Desmos, find what 600 times 0.39 is. And I get 234, so that's my mean. So the mean is 234. It'd be people, right? That's the mean. Oops, mean. I cut off my N there. All right, so then what about the standard deviation? Well, again, we have a formula for that as well, and a symbol. So it's sigma, which is the square root of NPQ. And again, we just say NPQ when we write it, but that's implying N times P times Q. Right, and they're all under that square root. So you're going to take the square root of, in our case, 600 times 0.39 times 0.61. Boy, it's convenient that we already found what those values were. All right, so I'm going to go to my Desmos, and I'm going to grab another line here. So I want the square root, so I'm going to type SQRT, or you could pull up the menu, and it's the little checkmarky one, the one that looks like a check mark. I'm going to say 600 times 0.39 times 0.61. And all of this has to be under that square root sign. And I get 11.947. I don't know how many decimal places they want it, but I'm going to go with that. So people. And there we go. We have the mean and the standard deviation. Part A is done. Okay, so let's see here. Oh, they only wanted one value. So that's fine. So interpreting the mean, well, if you poll 600 people, the mean is the center of that. So it's the expected value, as it were. So if you poll 600 people, we expect 234 of them to say they think the state of moral values is poor. I can't guarantee they'll write it exactly like that, but I can approximate what they're going to write here. So interpret the mean. So that would be saying out of 600 random adults, we expect, and that's the key, we expect 234 of them to believe that the overall state of moral values is poor, right? So you expect this many successes. All right, so that's good. Done with that bit. And then let's see what else they want. There's one more section, I think. So we did that. Would it be unusual if 200 or 212 of them, of the 600 adults surveyed, believed that the overall state of moral values is poor? Okay, so they're using the standard deviation method. So they're kind of saying, hey, we could do the mean, take away student standard deviations, and the mean plus 2 standard deviations. So we can do that. I mean, that's old school. We did that a long time ago in chapter 3. So let me go back to this sheet. Okay, so and what was my number? I forgot. I forgot already. 252? Would it be unusual if 212 of the adults surveyed? Okay, would it be? I don't know why I'm typing this when I could just go copy and paste it. That's because I'm being silly is what I'm doing. Okay, so unusual. Unusual is 2 standard deviations away. All right, so let me find the mean take away 2 standard deviations and the mean plus 2 standard deviations. So let me just reminder. 2 standard deviations away from the mean is considered unusual. Okay, so I'm going to find the mean take away 2 standard deviations. Well, the mean was 234, and I'm going to take away 2 times the standard deviation, which was 11.9. So I just need to find what that value is. And again, in mathematics, we don't put the symbols between multiplication a lot. We'll just say 2 sigma. But what that means is 2 times that value, right? And we can denote that with either a little times dot, or we can put parentheses around the 11.9. But either way, we want to do that. All right, so let me go to Desmos. 234 take away 2 times 11.9 is 210.2. All right, so that value is 210.2. So 212 is not past that, right? It's not below that. And while I'm on the same subject, I should actually find the other unusual value, because there's another one. If I add 234 plus 2 times 11.9, that gets me 257.8. So anything between those values is usual, if you will, right? Something I expect, right? So you'd have to be lower than 210.2 would be unusual, and also above 257.8 would be unusual. 212 is neither, so therefore 212 is not unusual. There we go.